Hello guys, in part 1 of my video on this series, partial fraction, I showed you actually how to resolve partial fraction with non-repeated linear factors at the denominator. Now in this case, it's going to be non-repeated but not linear, okay, factors at the denominator. So let me show you what it is. Now to resolve this into partial fraction, I can notice something. Look at this factor and look at this factor. All right. I noticed something. You see, one of them, the one at the numerator is a factor of the one at the denominator. So this is what I'm going to do. I will simplify it further so that I have x minus 1 into x squared plus x plus 1. Cover it like that in the bracket. Then you see this is actually difference of two squares, so I'm going to have x plus 1 down into x minus 1, then into 3x squared plus 4x plus 3. Now if you check it out, this will cancel this out. So what I have in essence is going to be x raised to power 2 plus x plus 1 all over x plus 1, then into 3x squared plus 4x, then plus 3. This is what I have to resolve into partial fraction. And I can actually do this, all right? Now, I want you to take note of something. You see, this is linear, but this is not linear. This is quadratic, all right? Now, from my previous video, I explained this. And I'm going to show you how to resolve this into partial fraction. Now, first, I have a linear factor, which is x plus 1. Then, plus I have a quadratic factor, which is 3x squared plus 4x plus 3. Now, let me let you know something. You see, once you have a quadratic factor like this, do not be in a haste to treat it as a quadratic factor. Check if it can be broken down, if it can be factorized. But you see, 3x squared plus 4x plus 3 cannot be factorized. Okay? Since it cannot be factorized, then we go to what I'm going to be doing now. Remember, this is linear, so the numerator is going to be just a constant. Now, but this is quadratic, so this is going to be bx plus c. It's going to be linear. Quadratic denominator, but linear numerator. All right. Now, since we have this, then we'll move further for to solve this question. So I have a. Now, if you check, to get the LCM is just a combination of x plus 1. Then we have 3x squared plus 4x, then plus 3. This is what I have. All right. So this is going to be a into 3x squared plus 4x, then plus 3. Then I have plus, I'm going to have x plus 1 into bx plus c. Now, if I put it side by side with the main question, which is x plus 1, x squared plus x plus 1 all over, I have x plus 1 into 3x squared plus 4x, then plus 3. You notice that the denominators are the same. Now, so the numerators will be the same. So at the end of the day, I have a into 3x squared plus 4x plus 3 plus we have bx plus c, okay, into x plus 1 will be equals to x squared plus x plus 1. Now, recall again, in my first video, I told you that we have two basic methods of resolving partial fractions. We said we have the cover-up method, then we have comparing coefficients. And I told you that each question is unique. Now, the better of the method we are going to be using here is comparing coefficients. Okay? But because of this particular factor, I can actually reduce the work by using cover-up before I now move to comparing coefficients. Okay? So how do I now do this? I want to take care to just get a straight away is by saying let x be equals to minus 1. Okay, if x equals to minus 1, I'm going to have a into 3, then I have minus 1 all squared plus 4 into minus 1, then plus 3, then plus I have b into minus 1 plus c. Okay, then into minus 1 plus 1, then is equals to minus 1 all squared plus minus 1, then plus 1. You see, the aim is this. You see, this is 0. Now, because it is 0, everything here cancels out. Okay, everything here cancels out to be 0. So I'm going to have a into 3, then I have minus 4, then plus 3. Okay, is equals to, here I'm going to have 1 minus 1 plus 1. All right, so I'm going to have 2a is equals to 1. So therefore it implies that my a is equals to 1 over 2. So I've gotten my a. Now, to actually have the comparing coefficient method to be done, it means that you have to expand. Okay, so I'm going to expand. Now check out what I'm going to do. You see, I'm expanding this. I'm expanding every term in this. So I'll start with this. A times 3x squared. I'm going to have 3ax squared plus 4ax plus 3a. Okay. Then plus bx times x is going to be bx squared plus bx, then plus cx, then plus c. Everything will be equals to x squared plus x plus 1. Now, since I have this, I will now continue like this. I'll bring out the coefficient of x squared. Now, coefficient of x squared here is 3a. The next is b plus b will be equals to, what is the coefficient of x here is 1. So I'm going to have this one as my equation 1. Then I'll go to coefficient of x. So I have 4a, all right, look at it, 4a, then plus b plus c, good, plus b plus c. Now this will be equals to 1, 2, so we are going to have equation 2. Then the last is carrying the constant term, which is 3a and plus c. So it's 3a plus c will now be equals to 1. Okay, this is 3. Why is it equals to 1? Because the constant term here is 1. Now, but recall, we said our a is half, 1 over 2. So therefore, I can quickly substitute it in the first equation, which is this. So that I'm going to have 3 into 1 over 2, okay, plus b is equals to 1. So I'm going to have 3 over 2 plus b is equals to 1. So my b is equals to 1 minus 3 by 2, which will be equals to minus half. So I've gotten my b. Now, I can actually get my c from substituting in the third equation. Now, substituting the third equation, I have 3, then I have a, which is 1 by 2, then plus c, then this is equals to 1 equally. So I'm going to have 3 by 2 plus c is equals to 1. So moving it, my c will be equals to 1 minus 3 by 2. So therefore, my c will be equals to minus 1 over 2 equally. So in summary, my a is 1 over 2, my b is minus 1 over 2, and my c is minus 1 over 2. Now recall, this is the expression for our partial fraction. Okay, look at it here. So I'm going to use this. Now, since I have this, then what remains is for me to substitute my coefficients a, b, and c. Now, substituting it in the first one, I'm going to have a is 1 over 2, so I'm going to have 1 over 2, then into x plus 1. All right. Then checking out, look at the B. All right. This, just check out what I'm going to do here. Now, this is going to be minus um 1 over 2x, then minus 1 over 2, okay, all over 3x squared plus 4x plus 3. Okay, I decided to expand it this way so that I can actually show you what is really happening. Anyway, just take note of this. All right, this is the answer now. This is going to be 2 into x plus 1. Then you see these two minus, they can come outside so that I have plus into, then I have minus, okay, then I'm going to have x plus 1, then all over 2 into 3x squared plus 4x plus 3. Okay, now finally I'm going to have 1 over 2 into x plus 1, then minus times plus here becomes minus, then I'm going to have x plus 1 all over 2 into 3x squared plus 4x plus 3. Now, you need to know that you have to break it down to simplify it to the simplest possible form, okay, which I have done. So this is my answer. Please don't forget to subscribe. I have more good and important videos coming your way. Thank you for being with me.